Good morning everyone. Welcome to our first tutorial video about the first chapter that you guys saw in class about introduction to operation management. First of all, by now I think everyone now is familiar with key terms like production, operation management, supply chain, the 10 strategic OM decisions, the difference between service and product, what is productivity and all those things. But this video, as we agreed in class, is not about theory, but it's more about calculation. So we are going to do just two exercises. One, all of them are based on it's in the book in the 9th edition according to the numbers. So you're going to see the video and then the exercise, and then from there you can try to find it in the edition that you have, because I know the latest one must be 11th. The one that I'm using right now is the 9th edition. But now, so far, you guys must be now familiar to the term of operation, like we said in class. But now, you must know first of all what is operation management and so on. So we say that before knowing operation management, you must know first what is production, and which is said that is the creation of goods and services. And then we define operation management as a set of activity that create value in the form of good and service. So it's everything that is involved in the production of a good or a service. So apart from that, this is just a baking company process that I would like to help you understand. First of all, it starts with the input. Let's say it's a company that makes cakes. So the process will be about, first of all, input, and the input is the labor that you're going to use first, which are the bakers in this case. And then after, we need the capital. Obviously, we need the capital to buy the facility where we're going to bake. We need that capital to pay the labor and all those people. And then after, we also need the material. The material that we need especially is about sugar, milk, eggs, and other component of whatever we're going to need. Then we are going to go into our transformation process, which is the baking process. In short, it's more about us now transforming everything that we have, using the labor to make the cake, using the sugar, the milk, everything that we are going to use to transform. And the final output is the cake that we're going to have. So this is the basic process of each and every company. We always have an input, a transformation process, and an output. So by so far, what we need to do is, we need first of all to understand productivity. So productivity is defined as the ratio between the units that are produced divided by the input that we use. So in our example here, the unit that are produced is the cakes, and the input that we use is the material, I will say the labor, the capital, and all those things. But now, we have two kinds of productivity, if we can say so. We have first of all the single factor productivity and the multi-factor productivity. Single factor productivity is a productivity that is focused only on one factor or on one input, if we can say so. So the output is the number of cake, but the input that we need to focus only is about labor, for example, or it can be material, or it can be the capital. That one we call single factor productivity. So in this case, for example, we still have our formula about productivity, which is the unit produced, in this case, which are the cakes, divided by the labor used, which is the bakers that we used. Now, if for example we produced 1,000 cakes and then we used 250 bakers who are our labor, so the productivity will be 1,000 divided by 250. I want you to focus more on the unit. The unit is gonna be cakes per bakers in this case, but most of the time we'll have it like in labor hours. So you divide 1,000 by 250, which gives you 4 cakes per baker. Now this is when it comes to labor productivity. But now when we need to do multi-factor productivity, you notice that we are going to have an output that is on top, which is always what we are producing. In this case is the number of cakes that we are making. We divide by the labor plus the material plus the energy, the capital, and miscellaneous. In this case, we mean all the things that you are going to use in productivity. But now, they say that the output and input are often expressed in dollars. What we mean is like the labor, most of the time they have their own unit. It can be labor hour. The material, they have their own unit. It can be meters, kilograms, and all those things. Energy, it can be kilowatt. Capital is money, and other unit. So for us to work this multi-factor productivity, we must make sure that all of those inputs are in one unit, which is an amount of money. In our case, we're going to use more rand because we're in South Africa. So they'll tell you, for example, that we are using 10 bakers that are paid, I don't know, 5 rand per hour, and they're working for 8 hours. So you're going to take the 10 workers that you have times 8, which gives you 80. That means those people are working for 80 hours, and they are paid 5 rand per hour. So to get it that amount in dollars, I mean in rand, it's gonna be 80 times 5, which gives you 400 rand. This is what those people are paid. Then if you transform all our unit, if we transform all our input in dollars, and we can add them, and then they are going to be divided by the output. So this is the end of this part here. What I want us to do now, I want us to do an exercise. As I said, the exercise that we're going to do is going to be based on this company here. It is the edition that I'm using, as I said, is the 9th edition, and it's an exercise 1.4. so in the book, I think it's page 57 or 58 in the 9th edition, but you are going to find this exercise into different, how to call them, in different books, but with not necessarily the same number. So you just need to see the problem and check in your edition which exercise it is. So the first question, I'm going to look at 2 questions, as I said. The first question is going to be about this one here. They are saying that Carbondale casting produces cast bronze valves on a 10% assembly line. On a recent day, 160 valves were produced during an 8-hour shift. So the first question, they want us to calculate, first of all, the labor productivity of the line. So as I said, it's Operation Management 9th edition by J. Render. So the first question, as I'm saying, it's 1.4. What we are going to do, first of all, we identify the data that we have. They say that there are 10 persons that are working on an assembly line, and there is an output of 160 valves that were produced during an 8-hour shift. So in short, our output is 160 valve, if we can say so, and then our input, in this case, the input that we are using is the labor hour. But now they say that we are using, how do we call it, they say that we are using 10% that are working on an assembly line, and those persons are working during an 8-hour shift. What they mean is, like, we have, first of all, 10 guys that are working on an 8-hour shift. Each of them is working for 8 hours. So the first one is working for 8 hours, the second is working for 8 hours, and so on. So it's true that after a day they're working for a shift of 8 hours, but it individually, each one of them must work for 8 hours. So the total number of hours that we must use is going to be 80. So we have 10% that are working for 8 hours. So we are going to do multiply it by 8 hours, and the value that we are going to have a total of 80 hours that these people are going to work on. But now the first question that they are asking is to calculate the labor productivity of the line. Remember what we said about productivity. We say that productivity is equal to the output that you are making, and we divide by the input. So in short, we divide by our input. But now in this case, the input that we are using is labor hour. Here's the labor hours that we are using. Labor hours, sorry. So this is the formula that we are going to use. Then what we do is our output, as we said, it's 160 valves. So we're going to say that our productivity is equal to 160 valves. Remember, always put your unit. You should not just put 160 and then you leave it like that, because we need to know how you are doing things. So we have 160 valves that we are going to divide by 80. Let's call it 80 labor hours. Then from there, the value that we are going to get after our calculation, 160 divided by 80, which gives us 2. So the value that we have is 2 valves per hour, per labor hour, if you can say so. Then the value that we have here, this is our productivity. It means that for each guy that is working for an hour is producing 2 valves, if we can put it in that context. I mean. But now what we need to do after defining it, this is, we are done with the first question. Then we go to our second question. They are saying that John Goodell, the manager at Carbondale, changed the layout and was able to increase the productivity from to 180 per 8 shift. What is the new labor productivity per labor hour? Remember, they're already telling you the unit. They say that is it must be the valve divided by the labor hour. Then from there, what we do is now we are on question B. In short, what they say that the guy, they've changed the productivity now. You must notice something, that the input didn't change. Those people are still working for 8 hours, but the productivity moved from 160 to 180. So we need now to calculate the new productivity. So the formula is still the same. The same productivity that we use here. But how do you call it? What changes only the output that change. So our productivity is going to be now the new productivity, the new, how do you call it, the new output, with the new output, which is let's just call it new output, and then we divide by our labor hour, which is our input, labor hour. So remember that the new output is equal to 180. So the new output is going to be 180 valves again. Then we divide it by the labor hour, which didn't change, is still 180, because the number of people and the shift that didn't change to is still 80. But then from now 180 we divide by 80, and the answer that we get is 2.25 valves per labor hour. So this is the input that we got. This is the productivity that we are going to get for our second value. So you see that before they are working with 160 people, they are working with 10 people producing 160, and the labor the productivity was 2. But now they change, they increase the output, they move from 160 to 180, but the input didn't change, which is still 80. Sorry, I forgot the unit here. Is 80 labor hour. So now the productivity increased. But the next question is about knowing, which is question C. They say, what is the percentage of the productivity? What is the percentage of productivity increase? So in this case, what we do is we identify, first of all, we need to use a specific formula. We can call it productivity increase. We can put it in that case and call it productivity increase. So let's call it productivity increase. So how do we go about calculating this productivity increase? So sorry, it's question C. So to calculate the productivity increase, what we do, we must use a specific formula, and that formula let me try to put it in this case. So it must be in a term of a fraction. Then that productivity increase will be, first of all, you have bracket. It will be the new, how do you call it? It is the new productivity minus the old productivity then we divide by the all productivity, the value of the all productivity that we add. Productivity. And then we are going to multiply that, because the productivity increase, it must always be in terms of percentage. Then we must multiply it by 100%, so that we can find the value. We can find the value in percentage. So in our case here, the new productivity is equal to 2.25. Productivity is equal to 225 valves per labor hour, and the old productivity is equal to productivity is equal to 2 valves per labor hour. So what we need to do, we have all the values, we just need to replace them by inside of our formula that we already have here. So this is the formula and everything inside. So we call it productivity increase. So the value of the new productivity is 2.25, and the value of the all productivity is 2. And we divide by the value of the old productivity again, which is still 2. Then we need to multiply it by 100%. So if we do 2.25 minus 2 and we divide it by 2, it gives us 0.125 times 100, we get 12.5%. So what does this value of 12.5% means? This value just means that since that guy, the manager, has changed the productivity, the output of the productivity, it moved from 160 to 180. It means that the productivity increased by 12.5%. So now in some exercise, you'll find that the value here of the new productivity is lesser than the value of the old productivity. Obviously, it's going to give you a negative number. Let's say, for example, that the value here was 1.5 minus 2. You find that you're going to find negative 0.5 divided by 2. You're going to find a negative number. It's not like it's a mistake. It's quite normal. It just means that the productivity decreased by that specific percentage that you guys are going to find. So do not panic whenever I find something like that. It just makes sense. If before I used to make 2 valves per hour and now I'm making just 1 valve or 1.5, as long as it under what I used to produce before, it means that I've decreased. The negative sign just means that the value of the productivity has decreased. So in short, this is all about this first exercise. Now you must understand, as I say, you identify first of all your value, you identify the productivity, the output, you identify your input, and from there you are going to change. Then we are going to go to the second question, which is question right. So we're going to go to our second question, which is question 1.7. is still in the same book in the 9th edition. But this one, the first exercise that we just did, as you notice, it's only a single factor productivity. It's only about labor productivity. But now this one is a bit more combined. We're going to use the multi-factor. So they are saying that George Caparizis makes bearing balls in his Miami plant. With recent increases in his cost, he has a newfound interest in efficiency. George is interested in determining the productivity of his organization. He would like to know if his organization is making the manufacturing average of 3% increase in productivity per year. He has the following data representing the amount from the last year and an equivalent month of this year. So I'm sorry first of all for the scanning because you cannot see properly, but these are the number of units that it produced, the labor, the resin, the capital invested, and the energy. But now this is for last year and this is for now what is using. So one thing that I want you to notice first, like the new unit produced here is what we call the output, and everything that is coming down here is the input. The unit produced didn't change from last year to this year, still the same. So what we do, first of all, you need to try to understand the problem. Now the question is about showing the productivity percentage change from each category, and then we need to determine the improvement for labor hour and the typical standard comparison. So what we do is, like, we must first of all, I just want to work it in a table format so that it can be easy. The first column is going to be about the data that we have. The second is going to be about last year. The third is for this year, and then the fourth, now we are going to calculate the the productivity increase. So here we have the data. Sorry, the exercise, I forgot to add. The exercise is 1.7. So we have the data, and here we have for last it's for last year, and this one, and the other table is for now, and then we need to check the productivity change. So from now, we say the first thing that we have is the unit that are produced. I can call it like U produced, which is another way we eat the output. So it said that last year the output were 1000 units, and now it's still 1000 units, so there's no change here. It's 1000 units, and here we still have 1000 units. So I just wanna, yeah, and then this one, I will say it's only the output. Now whatever is coming now is the input. So we have the labor hours that were used. So last year they used to use 300 hours to produce everything, and now they are using 275. So it's 300 and 275 for now. And then we need to do the quantity of resin that they use. The unit here, they're saying that it is in pound already, and here it's in hour. So last year they used 50 pounds of resin, and this year they are using only 45. So 50 and then 45. And after that, we need to use the capital investment and the energy. So we have the capital that they use. The unit of the capital here, they are saying that is in dollar, but because in South Africa they just use the rand. So yeah, and then the value that they used last year, it was 10,000, and this year they used 11,000 like a capital to start their business with. And now the energy that they used, the unit that they use is BTU, and from there the unit that the quantity that they use is 3,280, 2850. So it's 3,028.50. So this is the amount. This is a summary of everything that they used last year. So yeah, I don't know if it's gonna fit on the table, but let me change the design of the paper and put it landscape. Yeah, and let's make it a bit bigger on an A3. So from here, what we need to do now is to calculate first of all the productivity, and then we are going to calculate the productivity change. Sorry, I forgot to add this table. So we are going to call this new column the productivity. So what we do, remember that we are still using our formula. I just need to whatever. Anytime that you guys are working on the productivity, you must always remember this formula. Sometimes it might not be given on your, how do you call it, no question paper, but you guys are supposed to know that this is the formula that we use. So remember that the productivity, this one is for labor hour, but in short, this is the standard formula of productivity. So the productivity that we are going to use is the output, and we divide by our input. So first of all, we need to calculate the productivity for the labor, because we cannot calculate the productivity for the output. So we start already with the productivity for our labor. The productivity in this case, we still have our output, so we still have our outputs. So we call it productivity last year. And we also have productivity now. So last year, our productivity for the number of hours, it used to be 1000, which is the number of units that we have produced. Then we divide by 300, which is the number of hours that we use. So it's 1000 units. Then we are going to divide by labor hours. I'm just going to put it LH. So the number, the productivity in this case is 1000 divided by 300, which gives us, so we're going to use just two decimals after. We're going to limit ourselves for 2 decimals, which is going to be 3.33 units per labor hours. So this is what they produced last year. So when it comes to the quantity of resin that they used, it's still 1000 units. Then we divide by our 50 pound, if we can call it like that, and then the value is 1000 divided by 50, which gives us 20. So we have 20 unit per pound used. Then for the capital that we used, the capital used in this case is still 1000 units that we're going to divide by 10,000 rand in this case. So the amount that is going to be used in this case, I mean the productivity, is equal to 0.1 unit per rand used. And finally for the energy, still 1000 unit divided by 3000 BTU, which is equal to 0.3 units per BTU. And then so we need to check the question. The question is still saying that we need to show the productivity percentage change for each category, and then we determine the improvement of the labor hour. So what we do next now is we calculate the productivity for, how do you call it, we calculate the productivity for now. Still the same method. We use 1000 units, which are the one that were produced now. They didn't change, in short. And then we need to divide by 275 labor hour that were used now this year. So we have 1000, we divide by 275, and the amount that we get is 3.6, because we have 636, so we're going to put it like 6.4 unit produced per labor hour. Then we do the same for the pound that we use, is still 1000 unit, but now they use 45 pound of resin. So 1000 we divide by 45, the value that we get is 22.2 units per pound of resin used. Then for the capital, we have 10,000, sorry, it's 1000 units that are produced over 11,000 rand. Remember that in this case we are using the rand. So we have 1000 divided by 11,000, which gives us 0.09. and the value here is in the unit per rand. And finally, when it comes to the energy, we have 1000 units that are produced again, that we're going to divide by 2850. Now this only 2850 is the energy that we are using right now, BTU, and then we have 1000 divided by 2850, and the amount that we get is 0.35 unit per BTU. So from now, what we need to do, we need to check the productivity change again. So we need to compare what it was last year. Remember that we still use the same formula that we used last year. For the previous exercise. So this is the formula that you are going to use. Yeah, this is the formula that you are going to use in this case. Just a bit bigger. I want to make it a bit smaller. I hope everyone can see from here. So the productivity that we have, just wanted to put the formula to remind everyone. What we're going to do is we have the new productivity that we're using minus the old productivity, and we divide by the old productivity. So in this case, the new productivity is the more recent, which is what we are using now, and the old productivity is the one that we used last year. In some exercise, they can just say that this is what they used in 2015 and this is what they used in 2016. So now you check between 2015 and 2016, which one is the more recent, which is 2016. So 2016 is going to be the new one and 2015 is going to be the old one. So in this case, the new productivity is the one that we're using right now. When it comes to labor, it's going to be 3.64 minus 330, then we divide by our old productivity, which is 330. So remember, we must multiply it by 100 to get our value in percentage, 100%. So it's 364 minus 3.33, and then we divide by 3.33. And then the value that we get is 0.093. Then we need to multiply it by 100. So that means that the productivity in this case, it has increased by 9.31%. This is the productivity that is involved in only the labor hour. And then the second, we do the same thing for the reason that we used. So this year we used 22.22 minus what we used last year, which was 20, and then we need to divide it by 22. No, sorry, we need to divide it by 20, and then we need to multiply the total by 100%. So we have 22.22 minus 20, and we divide by 20, then we multiply by 100, and the value that we get is 11.1%. They just mean again that the productivity has increased. Last year, the productivity has increased because last year, although we have the same amount of units that were produced, but the input now were reduced. Last year we used 50 to make 100 units, but this year we used only 45 to make 100 units. So in short, we increased the productivity. And we need to check also for the capital. Still we use the same formula. The capital that was used last year, this year now is 0.09. But now this year we use 0.09. It was the productivity, and last year the productivity was 0.1. So we need to divide it by 0.01, and we multiply it by 100. 0.01, then we multiply it by 100%. So I want you to notice something here. If we do 0.09 minus 0.1, we are going to get the negative number, and then we divide by 0.1. Sorry, this one here, it must be 0.1. Yeah, and we divide by 0.1, then we multiply by 100. The value that we are going to get is a negative value, which is negative 10%. Negative 10%. This percentage here just means that it has decreased, that the productivity decreased, in short. But we cannot put it like just to say that a negative percentage. So just to put it on a more convenient, we can just say that it decreased by 10%, because that value is negative. Then we do the same thing for our energy. Then we know that we have produced 0.35 unit this year, which are going to minus but by the 0.3, which is the productivity of last year. Then we are going to divide by 0.3 again, and we multiply everything by 100%. Now the value that we get is 0.35 minus 0.3. We divide by 0.3 and we multiply by 100. So in this case we have a positive value of 16.67%. In this case they just mean that the productivity has increased. But as you have noticed, I think that this exercise is also about single factor, because the productivity that we are calculating right now is also about finding the productivity for each output compared to each input that is used. So I think in the next video I'm going to talk about now only multi-factor. I'm going to do one exercise just to remind you. But I just hope that this video now was useful. Now you can be able now to understand how we use the single factor productivity, and on top of that now how to check if the productivity has increased or not. So there are many ways to find the productivity increased. Some can help you to find the productivity in one way and explain it. It just depends on the matter on how you explain it. So in my case, I just hope that the way I explained was easy and you guys understood. So if you don't understand this video, just come with the same exercise in class. I can help you. And yeah, I'm waiting for feedback, hoping that this video was helpful. Otherwise, thank you so much, and yeah, see you next time.